For question 4, we've been given that sine 24 is equal to m, while cos 35 is equal to n. And this way of going around these questions is by drawing your diagrams first. We have two triangles. We know that sine 24, sine is made of y over the hypotenuse. This is going to be our angle, 24. Our opposite is going to be m. Our hypotenuse is going to be 1. So we need to find this value. Can use our Pythagorean theorem. M squared, 1 squared. X squared is equal to 1 minus m squared. X is equal to the square root of 1 minus m squared. That's the value that we have here. Cos 35 is equal to n. This is 35 degrees. You know that cos is adjacent over the hypotenuse over 1. X squared plus y squared is equal to r squared. X n plus y squared is equal to 1 squared. Y squared is equal to 1 minus n squared. Find square root of 35. Therefore, this side is the square root of 1 minus n squared. The first question is asking us to find tan 66 degrees. This is 66. 90, 24, 66 degrees. Tan, as we know, is opposite over adjacent. So opposite to 66 degrees is the square root of 1 minus m squared. The adjacent side being m. That's our solution for this one. For our second one, we have sine 70. We know that we can write 70 in a different format. We can say sine 2 multiplied by 35 multiplied by 35. This becomes an identity to sine 35 cos 35. Sine 35 becomes opposite the square root of 1 minus n squared over the hypotenuse multiplied by cos, which is n over 1. The numerator is multiplied out is 2n square root of 1 minus n squared. Over 1, that's 2n square root of 1 squared. In this question, we need to prove that sine of 45 plus x multiplied by sine of 45 minus x is equal to cos 2x over 2. These two are identities, so we're going to expand them first. Sine 45 plus x plus cos 45 sine x multiplied by sine 45 plus x minus cos 45 sine x. If we multiply it throughout, we're going to get sine 45 plus x sine 45 plus x minus sine 45 plus x multiplied multiplied by cos 45 sine x. This one plus cos 45 sine x multiplied by sine 45 cos x. And then finally minus cos 45 sine x cos 45 sine x. These two are the same thing. And because this one is positive and this one is negative, we're going to cancel them out. But these two are different from each other. If you realize, we actually have sine 45 and sine 45. And remember, these are products. So they're multiplying each other. As well as cos x, cos x. Another way of expressing this is by saying sine squared 45 multiplied by cos squared of x minus the same thing can be said here. Cos 45 sine x sine x cos squared 45 sine squared x. But you also know that 45 is a special angle, so we can substitute sine as going to be square root of 2 over 2 squared multiplied by cos squared x minus square root of 2 over 2 squared multiplied by sine squared x. This is going to be 2 over 4 cos squared x minus 2 over 4 sine squared x. We take out the common factor, which is 2 over 4. We're left with cos squared x minus sine squared of x. This is going to be 1 over 2 multiplied by cos squared x minus sine squared x is also an identity of cos 2x over 2. This special angle sine 45 and cos 45, although I've written the square root of 2 over 2, you can also write it as 1 over the square root of 2. We generally don't want the square root in the denominator, so to try and remedy this, we usually say multiply the numerator and the denominator by the square root of 2. The square root multiplied by the square root takes out the square root, so underneath we have 2. This, we have the square root of 2. Thus I have the square root of 2 over 2 for sine and cos of 45. This question is a general solution question, but an interesting thing about this one is that we're given a restriction of what negative 180 and positive 180. We're going to apply that at the very end. So we have cos of x plus 42 is equal to sine 2x. The sine 2x can be written in another way, where we have cos x plus 42 is equal to cos 90 minus 2x. On the left hand side, we have cos of a particular angle, as well as on the right we have cos of a particular angle. Because these two expressions have the same trig function, we are going to equate them. X plus 2 is equal to 90 minus 2x. This is going to be our reference. So this is going to be our first solution. First case, we're going to say x plus 42 is equal to 90 minus 2x plus k 360. We solve for x, take 2x to the other side, We have 3x on this side, and then 42 on that side. We have 48 plus k 360. We're looking for x divided by 3 divided by 3. This x is going to be 16 plus k times 120.